Welcome back. Let's do question 2.2. If the sum of a sequence with this general term is equal to 20 and 1 over 6, determine the value of k. Right, so what can we do here? We have to find the sum of an arithmetic series. So let's find the first term, second term, and third term. I want to find the common difference here. Okay, so the first term, please take note, to get the first term we substitute 0. Then to get the second term we'll substitute 1. To get the third term we're going to substitute 2. Okay, we start from 0. It means from 0 up to k. T1 is going to be 1 over 3, 0, plus 1 over 6, which is equal to 1 over 6. And then T2, we're going to substitute 1. We started with 0, so we followed by 1. So T2, so we substitute 1, so 1, then plus 1 over 6. Then 1 over 3 plus 1 over 6, just the same as 2 over 6 plus 1 over 6, which is equal to 3 over 6. Okay, let me leave it as over 6. Let me not simplify it so that you can easily find the common difference there. And then our term number 3, we're going to substitute 2. So 1 over 3. So where there's p, we put 2. 2, and then plus 1 over 6, which is 2 over 3 plus 1 over 6. It's just like equivalent fraction for this one, 4 over 6 plus 1 over 6, which is 5 over 6. So we have our terms 1 over 6, 3 over 6, 5 over 6, like that. So if you check here, 3 over 6 minus 1 over 6 is 2 over 6. 5 over 6 minus 3 over 6 is 2 over 6. So our common difference is equal to 2 over 6, which is equal to 1 over 3. So the common difference is 1 over 3. When you're adding these terms, we get 20 and 1 over 6. So we have to substitute in the formula. Sn is equal to n over 2, then 2a plus n minus 1 d. So our Sn is 20 and 1 over 6. So we have to change this from a mixed number to an improper fraction. 6 times 20 is 120. 120 plus 1, 121. 121 over 6 is equal to n over 2. 2 times our a. Our a is 1 over 6 plus n minus 1. Then our common difference is 1 over 3. And then we can multiply both sides by 2 to get rid of this denominator 2 there. Let's multiply by 2 there. So we multiply times 2 times 2. 2 divided by 2 is 1. Then 2 into 6 there is 3. So we remain with 121 over 3 is equal to n. And then 2 times 1 over 6 is 1 over 3. Plus, we've distributed 1 over 3 there. So it becomes 1 over 3 n minus 1 over 3. Right, 1 over 3 minus 1 over 3 is 0. So we remain with 121 over 3 is equal to n times 1 over 3 n. Then we can multiply n times 1 over 3 n. 121 over 3 is equal to 1 over 3 n squared. Now to get rid of the denominator, we multiply by the LCD. So our denominator is 3, so we say times 3 there, times 3 there. So we get that 121 is equal to n squared. And then we find n. So therefore, we can square root both sides or use the difference of two squares. So n is equal to positive or negative 11. But n cannot be a negative integer. It's always a positive integer because it's number of terms. Therefore, n is equal to 11. But now, remember we're asked to find k. You have to be careful here. Okay, how do we find k? This is the number of terms. And then this k here is not the number of terms. It shows us that we substitute 0 into our general term up to k, isn't it? So now, how do we get the k? We know that from sigma notation, the number of terms is the top number minus the bottom number plus 1 to give us the number of terms. So if we say k minus 0 plus 1, we must get the number of terms, which is 11. Okay, and then k plus 1 is equal to 11, k is equal to 10. So we're substituting from 0 to 10. So there'll be 11 terms. K is equal to 10.